not that much. Two angles that equal 90 degrees are called complementary angles. Two angles that add up to 180 degrees are called supplementary angles. Now here's example one. You will definitely have charts like this in your reviews and on your quizzes and tests. So if my angle is a 25-degree angle, what angle would be the complement to that angle? Meaning what angle added together with 25 gives me 90? 65 degrees. So a 25-degree angle, the complement to a 25-degree angle is a 65-degree angle because together they add up to 90. If my angle is 25 degrees, the supplement to that angle would be 155. Now here's the trick with these tables, is that it always is angle, what's the complement, angle, what's the supplement? Meaning the complement and supplement, we don't link together at all, okay? So when it gives me a complement, I can't then be like, oh, well, the supplement is 140. That's the supplement to the complement, and that makes no sense. Okay, so we always have to go, if we're given a complement or a supplement, we have to find what was the original angle, which here the original angle would be, if the complement's 40, the original angle has to be 50. Why is that?
Because it has to add up.
Adds up to 90. And then from there, okay, if my original angle is 50, then the supplement to this angle is, yeah. Okay, so that's the tricky piece that kids mess up. So if you're given a complement or supplement, you always got to find the angle first, and then you find the missing piece. Yeah. Here's the other type of examples you may have. So I'll give you one for both. Here's 90-degree angles. I'll break apart this section. So there's a diagram. Doesn't necessarily use the word complement, but I see 90-degree angles there, and I know that I can use angle addition. So I can say 11 plus 3x plus 7 has to equal what?
Oh, no, it has to equal 90.
Has to equal 90, okay, because it's creating a right angle here. So 11 degrees plus 3x plus 7 equals 90, and now I just have an equation to solve. It's just like last unit or the beginning of this unit where we just had a generic angle given to us, and we knew that the part plus part equals whole. Now, it's not necessarily telling us an additional thing for the outside of that angle. It's just marking at 90 degrees, but I can still solve it. 3x plus 18 equals 90. Subtract 18. 72. Good. X equals 24. Okay, so another thing we may see with these 90 and 180 degree angles is a problem like that. The 180 degree ones tend to get students a little bit more because it's not marked like in the same way this is marked 90 degrees. So here's a diagram. Okay, a little bit tricky there. Yeah, so I drew a straight line, then I drew an angle coming off and a different angle on the bottom. So it's not a line going through it, it's just two different angles. And then I'll call this 3x plus 5 over here. And 5x plus 7 over here. Now, it didn't tell me anything about the bottom half of that diagram. The bottom half of that diagram is just a distraction to try to mess with me, okay? What it gives me is two angles that together create a line. They're creating a line, which tells me that this angle, 5x plus 7 plus this angle, 3x plus 5, has to add up to 180 because I know that a 180 degree angle creates a line. So when my diagram gives me a line, two angles, then that's my equation that I can set up. And then same idea, I can solve from there. So I have 8x's all together. 7 and 5, so plus 12 equals 180. Subtract 12. And 8x equals 168. What is 168 divided by 8? It would be 21. Because 8 goes into 16 twice and into 8 once. So 21.
When?
20 times 8.
So
60.
why did you teach me that a long time ago?
It was just evenly divisible.
I think it's a little past
I didn't
the
learn
12.
Brazilian.
The normal multiplication table it stops at 12.
Yeah.
So,
Okay, so that's our special angles. We'll see those a lot. Complementary, supplementary, or 90 and 180 degrees. Now this next one, I can't remember if we've mentioned it already. These never go away. They are with us for pretty much every single unit this semester. Vertical angles. Vertical angles are congruent or equal to each other. So I'm going to label this 1, 2, 3, and 4. Now, vertical angles aren't always vertical. Okay, vertical angles are angles that are not adjacent in this crisscross pattern. So 1 and 3, they happen to look vertical the way I drew it. These are vertical angles. 2 and 4 are a different vertical angle pair. Okay, and we will see this throughout geometry. So 1 and 3 are congruent. Let me grab a different color. 2 and 4 are congruent. Those are our vertical angles. And I'll give you an example too. Measure of angle 2 equals the measure of angle 4. Sometimes this looks like this, and not just two lines intersecting. Sometimes it's like triangles that meet. And if I know that this is 2x plus 23, and this is 6x subtract 1, anytime we have this x that's created when lines crisscross, that's giving me vertical angles. So I know that these angles are equal, are congruent. So my equation that I would set up would be 6x minus 1 equals 2x plus 3. Supposed to be 2x plus 23. And then we would solve from there. So I subtract 2x. And 4x minus 1 equals 23. Add 1. So x equals 6. Okay, so different looking diagram, different relationship. Those are equal. And the last one's really not anything mind-blowing, but perpendicular lines we talked about when we talked about slope. Perpendicular lines, we just want to know if it says that word that they're intersecting at 90 degrees. So it's creating a 90-degree angle. Not even going to talk about the theorems about perpendicular lines right now.